Hello, I'm Dr. Nicholas Salome, professor of physics here at Wichita State University. This week, we're hosting Professor Joseph Haley of Oklahoma State University as our physics department seminar speaker. Professor Haley does his research at CERN at the ATLAS experiment of the Large Hadron Collider. And today, we're here. In the background, you can see for myself, the LHC Atlas experiment with a couple of technicians working on it. And for Professor Haley, he's there at the CERN tunnel where the accelerated particles or protons are made. The seminar is going to be on September 4th at 2 p.m. to 3 p.m. in Jabara 226. So welcome, Joe.
Thank you very much for having me. I look forward to it. This will be my first time up there. So actually, I think I've gone through Kansas before, but first time giving a talk in Kansas, so looking forward to it.
Oh, great. So one question that comes to mind by a lot of our students is, how did you get into particle physics and this particular type of collider research?
Yeah, I mean, I was just always, as a kid, drawn to physics, and I had a really good freshman physics teacher in high school, and it just clicked with me that physics is what I wanted to do, and then went to undergraduate, University of Washington. I got degrees in physics and astronomy, and at undergraduate I did research actually in small scale gravity physics, so not particle physics, but I applied to the these REU programs, which are really good programs, and did an REU at the University of California, San Diego, in the particle physics group there, and it was just really interesting. I knew nothing about. I got there and they said, have you heard of the Higgs boson? I was like, no, never heard of the Higgs boson. But I was did some research basically before CMS turned on. That was kind of like preparing for the CMS experiment, which is the kind of sister experiment to ATLAS at the LHC. For looking for the Higgs boson. So I did that and had a great time, and then said, well, this is what I want to do. So then I applied to graduate school, and the rest is history.
Oh, great. So everyone knows, of course, CERN's a really big place and these experiments are really big. So is it difficult working on an experiment that's on another continent far away from Oklahoma and such a large experiment with a large number of people?
Probably yes and no. I think it's all relative. It depends on what you're used to. It is, it would be nice to have a tabletop experiment, go into the physics department basement or something and have it there. Like when I was an undergraduate working on these small scale gravity experiments, it was literally a lab in the basement and you could go in and work on it. However, these projects are so big, like really multi-billion-dollar projects, that can't be done in university. Really, you need the whole world to come together and collaborate, and make these joint efforts. And so it's only possible because we can kind of give everyone from all corners of the earth to pitch in. But then that said, actually with Zoom and the internet, of course, the World Wide Web was created by Berners-Lee at CERN to share data with Slack. And now, the World Wide Web basically makes it possible to collaborate over these large distances. It's nice to go there in person, although usually we try to send our students, and we usually have a postdoc or two from our group stationed there. So we actually have 3 faculty at Oklahoma State University working on the ATLAS experiment, doing different searching for different types of physics or different physics measurements, and also working on the future upgrade to the tracking system. And then we have a couple postdocs and probably at any given time 10 to 12 graduate students. And so we usually have 1 or 2 postdocs who are actually at CERN full time, and then we try to send usually as many grad students as we can. Usually 1 or 2 grad students will be over there. And then otherwise we do it remotely. And, a lot of it is data analysis. And so data analysis you can kind of do from anywhere. But yeah, no, it would be nice to have a collider in our basement here. But in the end, with the internet and Zoom and having students stationed there, it's actually not too bad.
Okay. Well, your talk on Wednesday, of course, is searches for vector-like quarks. And maybe you could give us a brief description of the physics without going into details of the seminar yet, because you're
Yeah,
going to have a whole hour to do that. But
I don't
maybe
want to spoil it.
just give us a few sentences on what is this about?
Yeah, I don't want to spoil it, the seminar. But it really comes down to this question of naturalness, and I kind of go into like what is naturalness, which is the idea of like, probability. If you were got to the beach and you saw, 10 rocks stacked up on top of each other in a nice tower, you probably guess somebody did that. It didn't just happen by chance. It wasn't just randomly these rocks stacked up. And of course, maybe you see 2 rocks, that can happen pretty easily. 3 rocks is less likely. And so you would say, well, it's not natural to just come upon, a huge stack of, teetering rocks. A similar thing happens in the standard model of particle physics, where the mass of the Higgs boson turns out to be extremely unnatural. What we observe in the standard model can only be explained if there's kind of parameters that cancel out to 16 decimal places, or really it's squared, so it's 32 decimal places, which is really unnatural. But then there's various theories that could explain why the Higgs boson has the mass it does without requiring it to be this fine cancellation. And supersymmetry basically can solve this problem, but we haven't found supersymmetry. And vector-like quarks also pop up in all these theories that are trying to address this problem. And so we're kind of searching for vector-like quarks. They would be a huge hint in the in the direction of what's the new theory that expands the standard model, because it is really, really unlikely that the standard model is the end all be all theory. So I'll talk about that, and then basically a couple of the searches that we've done, like how we actually then look through the data and try to find if vector-like quarks exist, and then the results. Do we see evidence for these particles, or what the latest results are?
Oh, okay. Well, it all sounds very exciting, and especially to me as a particle physicist also. I look forward to hearing your talk and your visit. I invite everyone to come to Jabara 226 on September 4th at 2 p.m. and listen to the talk. If you show up 20 minutes early, there's coffee and cookies. So
I'll definitely be there 20 minutes early then.
All righty. Thank you very
so much,
much.
Nick. I look forward to seeing you next week.
Okay. Bye.